So as a process executes, it changes its states by running, new, waiting, abort, and terminated. So in this area, so we have the diagrams of process states are new. So once it is the new process, it will be entered into the new state. And if it is ready for the execution, it enters into the ready state, and it goes to the waiting state, running, and terminated. So these are the states we have for process and process control blocks, which have the process states, process number, process counter, registers, memory limits, and limits for all the access process. CPU switch from process to process. So from process 1 to process 0 to process 1. So it first executing it, and it goes to the ideal state, and it will be executed as per the forms. So it comes to the thread. Thread is a execution of the single process which consider having multiple program counters per process. So multiple locations are execute at once and must then have storage for thread details. So which have the abundant supply for multiple PCBs. So in this process representation in Linux, so we have a scheduling programs, process scheduler, job queue, ready queue, and ready queue and various IQs are represented by using the registers, the head and tail. So the quick queue header will be executed for as a queue, head and ready and queue, and for the registers and so on. This PCB will be executed as per the norms. The queuing diagram represents the queues, resources, and flows, and goes on. So this, once the queue is ready, so it goes to the CPU and input output request and time slice required, and for the child, and wait for an interrupt. If the child is interrupted, it will control the control will pass to the interrupt occurs, then it goes for the ready queue. So these are the states representation we have for PCB. And scheduler, so we have short term scheduler, long term scheduler. So in this we have all the abundant input output process will be CPU bounded process will be executed, and degree of multi-programming will be executed as a long term scheduler, which have the process for addition. So in terms of medium term addition, the swap function, swap in and swap out, will be executed as such as. And this multitasking in mobile, so which is a single foreground process and background process and services which we have for the executed state. So comes to the context switch. When the CPU switches to another, the system must save the state from the old process to the new process via the context switch. Context of a process represents in a PCB which have the various threading process and operations on PCB. So process creation, process termination, and so on will be detailed discussed over here.